Hello guys, good morning everybody. My name is Shekhar Bhad, lecturer in physics, still working at DSM College Chintur, District Parvani. All you are most welcome in our online classroom. Dear students, today we are going to learn the definitions, concepts, optical phenomena which are related to the light in the chapter wave optics, which is already included in the syllabus of 12th standard. Wave optics. Let us discuss about the first what is meant by the optics. Optics is the branch of science which deals with the scientific study of light and its behavior. Then there is a sub branch that is called as the wave optics. Wave optics, it is the branch of optics which uses the wave nature of the light to explain the different optical phenomena like reflection, refraction, interference, polarization, diffraction, formation of images by the lenses and the mirrors. We have already learned in the 9th or 10th standard that light is travels through the medium from one place to another place, and this is called as the propagation of light. We know that the light travels from one place to another place in the straight line path. The motion which is along the straight line path is called as the linear motion, and therefore as the light travels along the straight line path, therefore this propagation is called as rectilinear propagation of the light, and the path of light is also called as the ray of light. Then to explain the propagation of light, properties of light, behavior of the light, and all these optical phenomena which are just related to this light, there were different scientists propose their different theories time to time. If you consider, there are near about 4 to 5 theories were laid to explain the behavior or the nature of the light. One of them are, first, Newton's corpuscular theory in 1675. First theory was given by the well-known scientist Newton, and this theory is called as Newton's corpuscular theory in the 17th century, 1675. The basic or the base of this theory that the light travels along the straight line path in the form of particle. That means the light has the particle nature according to the Newton's corpuscular theory, but there were some drawbacks, demerits in this theory, and therefore some optical phenomena could not explain on the basis of this Newton's corpuscular theory, and at that time this theory was discarded. Later on, In 1678, the another scientist, Huygens, proposed his theory, and the base of this theory was wave nature of this light, and therefore this theory is called as Huygens wave theory. In 17th century, particularly 1678, Huygens proposed his theory whose base was the wave nature, that means light travels from one place to another place in the form of wave. Again, there are some drawbacks which could not explain by this Huygens, and therefore again this theory was discarded. Later on in 19th century, the theory or the well-known scientist Maxwell proposed his theory, and that is called as the third Maxwell's electromagnetic theory in 1870. Maxwell proposed his theory, Maxwell's electromagnetic theory. That means light travels in the form of electromagnetic waves which are already transverse in nature. What is meant by the electromagnetic waves? Already we have studied in the 11th standard. Electromagnetic waves means the waves which are produced when electric field and magnetic fields are acting mutually perpendicular to each other. These electromagnetic waves are produced. The velocity of these electromagnetic waves is near about 3 lakh km per second. That is a tremendous velocity, and this light travels in a given medium, also in vacuum, with this velocity. Later on, another scientist, Planck's quantum theory. Planck proposed his theory that light travels again in the form of the particles, and therefore another theory is Planck's quantum theory. In 1905, the scientist Max Planck proposed his theory that the light travels in the form of particle, and he called as the photon. That means light travels in the form of photon from one place to another place, and its equation, that means the energy of this photon, is given by E is equal to h into nu. This is the equation of this energy of the given photon. And later on, the scientist de Broglie's hypothesis in about 1923. 1923, another scientist, de Broglie, proposed his theory, and some optical phenomena are explained on the basis of the wave nature of the light, and some optical phenomena like photoelectric effect are explained on the basis of the particle nature, and therefore this light, according to de Broglie, the light has dual nature. That means light travels in the form of wave as well as light travels in the form of photons, that is the particle. These are the theories which are related particularly to this light or propagation of light. Let us discuss about these two theories, Newton's corpuscular theory and Huygens wave theory. These two theories are included in your syllabus. Therefore, let us discuss about these theories step by step. Let us discuss the first, Newton's corpuscular theory. Dear students, let us discuss about the first theory, Newton's corpuscular theory. According to this Newton's corpuscular theory, Every source of light emits extremely minute particles called as the corpuscles. Every source of light emits the minute particles called as corpuscles. These minute particles are called as corpuscles. Corpuscle is the Latin word, and therefore, according to theory, whenever light is emitted from the source, this source emits these particles, and these particles travel along the straight line path. According to this Newton's corpuscular theory, these particles are, or the corpuscles are, rigid, massless, and perfectly elastic. These corpuscles are rigid, that means tough, massless, having a very small mass, and the perfectly elastic, that means they should undergo the elastic collision. Now, when third postulate of this Newton's corpuscular theory is when these particles are emitted from the source of light, they travels with a very high speed in the absence of any external force. When these corpuscles are emitted from the source of light, they travels with very high speed in the absence of any external force. These particles has the tremendous velocity. When these particles travel through a given medium, the speed of these corpuscles is different in different media. Velocity of light changes as the medium changes. Rarer medium, denser medium, for example, air, vacuum. These are the rarer mediums. Water, glass, any transparent liquid, that is the denser medium as compared to this air. When this light travels through any medium, the velocity of light is depend upon the given medium, and therefore the velocity of these or the speed of these corpuscles is different in the different media. Then we know that the light has the different colors: blue color, yellow color, red color, green color. The different colors of the light are due to different sizes of these corpuscles according to this Newton's corpuscular theory. Different colors are due to different sizes of corpuscles. Nature of color depends upon the size of this corpuscle according to this Newton's corpuscular theory. Then Newton explained the two optical phenomena. One is reflection and another is the refraction. According to this reflection, how the reflection occurs? When these corpuscles which are emitting from the source of light, when these corpuscles are strikes on this reflecting surface, for example mirror or the polished surfaces, when these corpuscles are strikes on the reflecting surface, then they undergo the elastic collision and that means corpuscles are repelled by the reflecting surfaces in the same medium, and this phenomenon is called as a reflection. When light strikes on any reflecting surface, it sends back to the same medium, This phenomena is called as the reflection. According to the Newton's corpuscular theory, when these corpuscles which are emitting from the source of light, they are going to strike on the reflecting surface, they undergo the elastic collision, and after elastic collision, that means corpuscles are repelled by the reflecting surfaces. Thus reflection, this phenomena is occurred during reflection. When this corpuscle strikes on the reflecting surface, they undergo the elastic collision and they are repelled by the reflecting surface, and thus the reflection, this phenomena is occur during refraction. During refraction, when these corpuscles are strikes on this refracting surface, for example glass, water, or any transparent medium, these are the refracting surfaces. When these corpuscles are strikes on this refracting surface, then the particles of this medium, that is refracting surface, they exert the large attractive force to accelerate these corpuscles, and then this refraction occurs. When these corpuscles are strikes on the refracting surface, the particles of the medium of refracting surface, example glass or the water, they, they exert the large attractive force on these corpuscles, and due to this reason they accelerated, and to accelerate these corpuscles this force is necessary, and thus this particularly the refraction occurs. These are the main postulates of this Newton's corpuscular theory. Then there are some drawbacks due to which this theory was discarded at that time. Let us discuss about the what are the drawbacks of this corpuscular theory. Dear students, let us discuss about the drawbacks of this particularly Newton's corpuscular theory. According to the Newton's corpuscular theory, these corpuscles are emitted from the source of light and they travel along the straight line path. As the light continuously or the corpuscles are continuously emitting from the source of light, therefore the mass of the source should be decreased. But experimentally it is found that this mass remains constant, and this is the first major drawback of this Newton's corpuscular theory. That means when these corpuscles are emitted from the source, its mass should decrease. But it remains constant. This is the first drawback or demerit of this Newton's corpuscular theory. Second, according to this Newton's corpuscular theory, the velocity of light or the velocity of these corpuscles, velocity of light in the denser medium is greater than velocity of light in rarer medium. But actually it is not true. According to the Newton's corpuscular theory, velocity of light in denser medium is greater than velocity of light in rarer medium, and which is not true. That means V suffix D is greater than V suffix R. This is the velocity of light in denser medium, particularly in case of velocity of light in the glass medium, water medium, when light travels through this medium, actually its velocity decreases. In case of this air medium or the vacuum, these are the rarer medium as compared to glass and water. The velocity of light in the rarer medium, in the air medium or vacuum is always greater than velocity of light in the glass medium or the water medium, and therefore this is the second major drawback of this Newton's corpuscular theory. Third, Newton could not explain the simultaneous reflection and refraction. In reflection, these corpuscles undergo the elastic collision and they are repelled by the reflecting surfaces. During refraction, these particles of the medium, that is refracting surface, exert the attractive force and they accelerate the corpuscles, and refraction occur. But at a time, reflection and refraction, that is called as the simultaneous reflection and refraction, this could not explain by the Newton, and this is the third drawback of this Newton's corpuscular theory, that simultaneous reflection and refraction could not explain by this Newton. Is the third drawback. And the optical phenomena like interference, diffraction, polarizations, these optical phenomena could not be explained by this Newton, and therefore this is the fourth major drawback of this theory, that interference, diffraction, polarization, such type of optical phenomena could not explain by this theory. And these are the main drawbacks of this Newton's corpuscular theory, and therefore at that time this theory was discarded. Later on, in year about 1678, the another theory proposed by the Huygens, whose base was the wave nature of the light. Let us discuss about the Huygens wave theory, its postulates, what are the merits, and again what are the demerits of this Huygens wave theory.